Hi guys, back again, and wanting to just continue on the theme of factorizing, but just look at factorizing difference of perfect squares. Just recap on, I'll just go here and have a look on this side so I don't have to rewrite everything. Here we've covered in the previous segment is that when you expand difference of perfect squares, you're going to have these two terms here. So a squared minus b squared. So there's your two terms. This is going to be, I guess, the set structure or the formula to which we're looking at. And we're going to go from here back to this. Okay? So when you're factorizing difference of perfect squares, it is very easy. Okay, so whatever the first term is, you're wanting to square root. Okay, so essentially whatever the square root of a squared is, which is a, goes in the beginning of each of the brackets, and then the square root of b squared is essentially b. Okay, what we can see from difference of perfect squares when you expand, the reason from being that it is D.O.P.S is that one is positive, one is negative. Okay, so what we need to do here is add a plus and a minus. So what happens here is you need to really be able to identify these two terms as perfect squares, be able to square root them, and then fill in the terms likewise. So let's put in an example here where we have x squared minus 16. Okay, so when you look at difference of perfect squares, both terms has to be a perfect square. Okay, and a value or a term that you can square root perfectly. Okay, so open your two brackets. One's going to be a positive, one's going to be a negative. What's the square root of x squared? It is simply x. What is the square root of 16? It is a 4. And it is as simple and easy and as quick as that. Okay? Let's do a couple more. Hopefully it will start to make some sense. I can explain it in various other ways, but I find this being the simplest and hope you find it also easy and see where I'm coming from. We have 9a squared minus 4b squared. Okay, if the question is asking you to factorize this difference of perfect squares, we're looking at the two terms and we can see that that is a perfect square and that's a perfect square. We can square root it. Okay, the square root of 9 is a 3. The square root of a squared is a. Okay, so the square root of this whole term is 3a. The square root of 4b squared, so if you square root the 4, you have a 2. And the square root of b squared is a b. So the square root of this whole term here is 2b. And as we can see in factorizing these terms, one has to be positive and one has to be negative. Okay. What I've said in the previous segment is if you're wanting to check your factorizing that you got it correct, you just expand the brackets. Okay. So using crab claw or foil as the likes, or in this case you can actually expand via difference of perfect squares, then you know that you're going to get that term or that solution. Okay, so that's great. Now something that probably looks a little weird and a little unfamiliar, but it all comes down to groups. Okay, remember in previous examples that you treat the brackets as one object. Okay, so notice that this whole object here, this group of x plus 3 in brackets, this whole object is squared. Okay, and so, and the 4 is also another perfect square. What we're going to do is we're going to open our two brackets, just like what we'd normally have been doing, and we're going to fill in the brackets as usual. Okay, so the square root of this group is simply x plus 3. Okay, the square root of 4 is a 2. What goes in the middle is a plus and a minus. What's different in this case as opposed to the other examples on the top is that we can actually simplify. So it is key to simplify where possible. So 3 plus 2 is 5. And then 3 minus 2 is 1. Okay, so a little bit different of the outcome, but notice, just know that you treat the brackets as one object, as a group, as you would normally do with other situations. Okay, now when you are factorizing, I might move this over here. When you're factorizing difference of perfect squares, it is not always going to be a perfect square, and sometimes you might need to enter the realm of surds. Okay, and so what I'll do is D.O.P.S using surds. By the way, going back to this one, I might just put a title D.O.P.S or Factorising D.O.P.S. So we're factorising difference of perfect squares here, and here we're going to be again factorising difference of perfect squares, but using surds. Okay, we'll do 3 examples here. X squared minus 10. Now, the x squared is a perfect square, but the 10 isn't. Okay? You're still going to have 2 brackets. You're still going to have a positive and a negative. So nothing changes. Okay? And there's a reason why I've used the examples of, or the explanation of square rooting the perfect squares. The square root of x squared is x, and the square root of 16 is 4. Okay, they work out nicely, so that's why they're perfect squares. Now, with a situation like this number, it is not a perfect square. Okay, but we can basically treat it as one. Let's start off with this term first. X squared, the square root of that is an x. Okay, that's simple enough, that's easy as it is. The square root of 10 is the square root of 10. Okay, so we have x plus the square root of 10, x minus the square root of 10. So the key thing here is, if you have a term that cannot be square rooted evenly or perfectly and simply as a whole integer, then you can treat it as a surd and it will be just the same. Okay, let's look at another one. X squared minus 24. Alright, so notice that 24 is not a perfect square. 25 is, but 24 just misses out. The square root of x squared is x. So that's totally fine. What's going to be positive? 1 is going to be negative. Now we can put the square root of 24 and then the square root of 24. We've turned it into a surd. But what's happening here is that the surd in itself is not in its simplest form. Okay? We can break the square root of 24 can be broken into the square root of 4 multiplied by the square root of 6. And then the square root of 4 is then 2. Okay? So breaking it into its factors, and then square root of 4 is a 2, and then what's left is 2 square root 6. So what you want to do in every scenario when you're changing a term into a surd, you're wanting to represent it in its simplest form. So now that we've simplified square root of 24 as 2 square root 6, we're going to put that into our terms. So x plus 2 square root 6, then x minus 2 square root 6. Okay. I hope you're traveling along okay. What's handy about these videos is if there's any part of any step that I've just gone through that you didn't get, or maybe I've gone too fast, you can always pause, backtrack, replay it, and watch it as many times as possible until you do, and hopefully these videos does the trick for you guys. Now, looking at this situation where we've got brackets, this is going to be one of the last examples, and we're going to have x minus 1 squared minus 5. Okay? Going to open up our brackets. Okay? Simple as that. Now notice that here we have a bracket squared, and then we have another term that's not so easily square rooted. Okay? Like the square root of 4 is a 2, but the square root of 5 isn't so much. Treat your terms or your brackets as one object here. We're going to put x minus 1 on this side, x minus 1 on that side. A plus is in one bracket and a minus is in another. The square root of 5 becomes a surd. So the square root of 5 is just the square root of 5. So they fill in the second half. What we have is now is x minus 1 plus square root of 5, x minus 1 minus square root of 5. Now, like I mentioned, in every case, if you can simplify it, do so. But when we look at this, we can't simplify it so easily. So I'm very happy to leave it as it is, and that will be the answer. Okay. So guys, that is factorizing difference of perfect squares using surds. The other case was just factorizing difference of perfect squares as naturally. Alright guys, this next segment is just factorizing by grouping, or factorization by grouping. And in previous videos I've given you a bit of a sneak peek, and here it is. So there's a segment here, and I'll show you what we are going to do. Let's have an example of x squared minus x, sorry, plus ax minus a. Alright, we've got 4 terms here, and that's really good, because what we can do, I'm just going to put a dotted line in between, and we're going to split the 4 terms into 2 groups. Okay, so we've got one group that has 2 terms, and we have another group that has 2 terms. What I want to do with each of those two groups is to actually factorize them individually first. Okay, so it's going to be a bit of a combination. The highest common factor between x squared and minus x. There's no common numbers, but if there are numbers, then do so. But in this case, there aren't, and we've got x being the highest common factor. Okay. X squared divided by x is x, and then minus x divided by x is minus 1. If you want to check that you've factorized this component correctly, expand. X times x is x squared, and then x times minus 1 is minus x, or negative x. So that's my first half. I'm going to do exactly the same thing to the second half. Okay? So looking at the two terms here, we don't have common numbers, but we do have common letters. A is in common, so I'm going to put A as my highest common factor. On the inside, AX divided by A is simply x. And then negative A, or minus A, divided by A is minus 1. Let's have a look if we've factorized that component correctly. A times x is ax, and then A times minus 1 is minus A. Now, if we just go back to this example that I went through earlier, I mentioned to treat any set of brackets as one object, a group, okay? And notice that these two brackets are identical. These two groups are identical. And what I've done here is I've made these identical brackets as our first set. That's our highest common factor. And in our second set of brackets, we're going to throw in the rest of the equation. So the x plus a goes into the second set of brackets. Okay? So when you have four terms, split it into two, factorize the first half, factorize the second half, and you'll find that you'll come across two identical brackets. That is what you should be looking at. If you don't have identical brackets, then something has gone wrong. Okay, so it's good to maybe just backtrack and see if you missed anything. It could be not getting the highest common factor, and so see if you can factorize it even further. Then you have your common brackets as your first part, and your outside terms as your second part. That is factorizing by grouping. Thanks guys, all the best.